Hello, everyone. In case you weren't aware, the Milky Way is the galaxy that we're currently in, and at its center there's actually a supermassive black hole known as Sagittarius A star. In fact, black holes are essentially the most extreme and most misunderstood objects in the universe, and we study them to essentially understand the laws that govern our universe. Now, you may have in fact seen this image here that's framed in blue, which is the first image ever obtained of this black hole, and that was released in 2022. Just to obtain this single image, it took several years of data processing and a whole global network of telescopes. Similarly to the EHT, the collaboration that obtained that image, for our research we use a combination of 5 space and ground-based telescopes that are all listed here. This allows us to probe different parts of the light spectrum and obtain new information. And you can imagine that we have to deal with an astronomical amount of data. In fact, ALMA alone, which is one of our telescopes, generates 1 terabyte of data per day. And this is scientific usable data, not just raw data. So on top of this difficulty, we also have to deal with the fact that the data that we collect is often very irregular due to all the noise between us and what we're observing. So here's an example of data we collected in 2019. So this graph essentially shows light intensities that were observed at different time frames over the course of 24 hours. And each box corresponds to a different type of light or wavelength that was observed using a different telescope, and that can give us different information. Now, the first thing I want to draw your attention to is the shaded region in gray here. I think we can all agree that just by looking at this with our eyes, we can see that there seems to be a certain peak in light intensity, and that this is true for most of the wavelengths that we're observing. Now, this suggests that there's a certain correlation between these different wavelengths, and it just so happens that whether or not there is a correlation between them can help us confirm or discard certain theories about the underlying physical processes happening right at the vicinity of the black hole, which is still very misunderstood at the moment. But of course, in science, we can't just look at something and then confirm it. We need to first quantify it. So we do this by cross-correlation analysis, where we essentially cross-correlate these different wavelengths. Now, the second thing I want to draw your attention to is the fact that there's so many gaps in the data, and there's even periods for which we have no observations at all. Now, you can imagine that when trying to cross-correlate this, it can be very difficult when there's so many gaps. So that's essentially the goal of our project. We want to interpolate our data, which means just to fill in the gaps. And the challenges that we face is the fact that our data resembles that of the figure on the right here, where there's multiple different channels, in our case wavelengths, with very sparse data, missing data, and essentially data that's observed at different times. It just so happens that in the medical field, there's a model that was produced called the TripletFormer algorithm that was designed to do exactly this, but for medical data. So we plan to essentially adapt this model and improve it and use it on our astrophysical data. Now, the architecture of this model is shown here on the left. I won't get too much into detail, but I'll just say that it is a probabilistic model, so it outputs a whole probability distribution describing our data when trying to predict new data instead of one single value, which is really important in our case. And it has an encoder-decoder structure with attention mechanisms. These attention mechanisms essentially allows our model to retain very important information over long sequences of time, which once again is exactly what we're looking for. So just to summarize, the goal of our project is to interpolate our multi-wavelength data, to then cross-correlate the augmented data sets and obtain a better understanding of the physical processes of the black hole at the center of the Milky Way. Thank you very much, and if you have any questions, please feel free to come see me at the break.